Hello students, welcome to SP classes of class 10. In today's class we will see our exercise 8.4, but before going that we will see some more trigonometric identities. Those are trigonometric identities. Okay, in this first main we are having, that is sin square theta plus cos square theta is equal to 1. For this, again some more changes further we can write as sin square theta is equal to 1 square cos square theta 1 or 1 square cos square theta. Again for this we can write as 1 square means a plus b, a minus b, that is a cos 1 plus cos theta and 1 minus cos theta. For this, again we can write as cos square theta is equal to, this cos square we are taking as separately, and we can write as 1 minus sin square theta. For this, again we can write as, how we can write for this, again in the a plus b a minus b form, or that is 1 plus sin theta 1 minus sin theta form. So for this one identity, this is the one main identity. From this we can write these more things. In the second main, like this type, what we are having means, that is secant square theta is equal to 1 plus tan square theta. For this, again we can write as, furthermore this is very important, that is secant square theta minus tan square theta is equal to 1. Okay, again for this we can write as secant square theta minus 1 is equal to tan square theta. Okay, I hope you all are understanding this one. Again this form we can write as secant theta plus tan theta into secant theta minus tan theta is equal to 1. For this one thing, again we have written some more identities. In the same way, third main we are having as cosecant square theta is equal to 1 plus cot square theta. Okay, for this we can write as cosecant square theta minus cot square theta is equal to 1. Again for this we can interchange, or we can write as cosecant square theta is equal to, or cosecant square theta minus 1 is equal to cot square theta. Again for this, cosecant theta plus cot theta, cosecant theta minus cot theta is equal to 1, or else we can write cosecant theta plus cot theta is equal to, for this only, this one we are taking as numerator, we are changing this one numerator to denominator, we are taking in this side. So 1 by cosecant theta minus cot theta also we can write. For this one main, for these main three identities, further we have interchanged and we have made in this way. So from this, by using this one only, we can solve our exercise 8.4. In that, let's see our exercise 8.4. First question, that is, express the trigonometric ratios sin A, secant A and tan A in terms of cot A. So what they are telling, first question, sin A, secant A and third one tan A. These three we have to change in terms of cot A. So for these things, how we can write in the term of cot A. So for that, first thing, this thing we already know, tan A is equal to 1 by cot A. This thing we already know before only. So third one we have done. So now let's see sin A. For this sin A, before going this, we know the identity, we know that which identity we are using here? Sin A is equal to 1 by cosecant A. Okay. For this, again, for this cosecant square theta is equal to 1 plus cot square theta. Just now only we have written this one. See here we have written cosecant theta is equal to 1 plus, or this one we can write as cosecant square theta is equal to 1 plus cot square theta also. So this thing only we have taken here. For this, cosecant theta is equal to square root of 1 plus cot square theta we can write. Okay. The same thing you put in this. So sin A is equal to 1 by, so in the place of cosecant A we are writing as 1 plus cot square root of 1 plus cot square A. So this thing we got. Now let's see our second one, that is secant A. Secant A, for this also we know our identity. We know one identity, that is secant square A is equal to 1 plus tan square A. This thing already we have know, secant square theta is equal to 1 plus tan square. The same thing we have written here. So tan already we have got here. So for this again we can write as tan theta is equal to 1 by cot theta. This thing also we know. Okay, for this secant A is equal to square root of 1 plus tan square A. Again, in the place of 1 plus tan square A means we can write as cot square A. Okay, whole square also, cot A whole square also we can write. For this, let's take LCM and let's do further more calculation, that is cot square A plus 1 divided by cot square A. Again for this we can write as secant A is equal to square root of cot square A plus 1 divided by cot 2A. For this again we can cancel this one and we can write as cot 2A plus 1 divided by cot A. I hope you understood this question. Let's see our second question, that is what is there in our second question. See, write all the other trigonometric ratios of angle A in terms of secant A. So here secant A, so remaining all we have to solve, that is cos A, tan A, sin A, cosecant A, now next cot A. These all we can write in terms of secant A. So for this also we are using some more properties. Do you all know about this? So for this first one, see directly we are writing first one, that is cos A. So cos A we already know, cos A is equal to 1 by secant A. This thing was clear here only. For the second one, we know that what we know that here secant square theta, secant square A is equal to 1 plus tan square A. Okay, this same identity, this one only. For this, furthermore, we can write as this secant one, secant square A minus 1, this thing we are taking and here writing as tan square A. So for this we can write as secant square A minus 1 is equal to tan A. This we got in the form in terms of tan A. So first one we got and second one we got. Now let's see our third one, that is sin A. For this sin A, how we can solve, we don't know about it. Okay, for this sin A, how we can do? So for this also we know some identity. We know that sin square A plus cos square a is equal to 1. For this, sin square a is equal to 1 minus cos square a. Again for this we can write as a sin a is equal to square root of 1 minus cos square a. Okay. After writing this one, how we can solve? Sin a is equal to, for this, cos means what is there? Cos means this one already we know 1 by secant. So square root of 1 by secant square a. Let's take the LCM and solve this one, that is secant square a minus 1 divided by secant square a. Again for this we can write as sin a is equal to square root of secant square a minus 1 divided by secant a. Okay, this thing you all understood up to here. Now let's see next one, that is our fourth one in the, that is cosecant a. For this cosecant a, 1 by sin a, we know that. So here already, so after this we can solve very easily. This sin a value we know, so sin a we got here, so just opposite of this one only we can get cosecant of a. So in the same way, sin a what we got here, that is secant square a minus 1 divided by secant a. So here we can write easily as cosecant a is equal to secant a divided by secant square a minus 1. This got our cosecant a. Next last one, cot a. For this cot, we know that cot theta is equal to 1 by tan theta. So tan theta already we got here. Here second one only we got here tan theta. For tan theta we got here already. Tan theta is equal to secant square a minus 1. So in the same way, let's put here the same thing, that is cot a is equal to 1 by tan a. For this tan a, what we have got here, that is 1 minus square root of secant square a minus 1. Okay, so directly this is only our cot a. Cot a is equal to 1 minus square root of a secant square a minus 1. So I hope you all understood these two questions. Let's continue in our next video. Thank you.